This is our virtual energy community. In the ideal world, we would be able to exchange electricity produced by our solar panels within our microgrid community according to our consumption and apply flexibility to it. For now, the regulations in Croatia still do not allow us to do so. Still, we can learn how it works and be better prepared for the time when enabling regulations will finally be in place. That will give all citizens the opportunity to actively participate in the electricity market, which is the ultimate goal we are advocating in the Green Energy Cooperative. In this educational video, we will take you through our pilot project of the virtual energy community and the services that showcase the potential of peer-to-peer energy trading. Let's start by understanding our user case, focused on exploring the concept of peer-to-peer energy trading and energy sharing within a virtual energy community. Imagine a multi-apartment building where residents share energy. It could also be a neighborhood with multiple houses. AI simulation of our virtual energy community help us explore how energy monitoring and self-consumption work. It provides insights into energy generation and consumption for each apartment and as a community within a microgrid. Here, we can clearly see what is going on in our virtual energy community. The green line shows us the photovoltaic energy generation. The red dashed line shows the need for charging the electric vehicle. Dashed yellow line shows heating and cooling needs. And the black line shows overall consumption. This information empowers us as residents and users to contrast our different energy profiles, to pinpoint prime sharing intervals, and to synchronize energy usage with production. From the previous graph, we were able to understand daily user profiles and habits, as well as the best time to be flexible in consumption, considering the produced energy. A new graph is presenting total electric energy needs in a pie chart, where the total amount of electric energy needs are presented, which can be useful for monthly predictions. Furthermore, we as users can learn about flexible energy appliances like electric vehicles, heating and cooling systems, and batteries. We can learn how their consumption time can be adjusted within certain limits for energy trading. In other words, we can see what amount of adaptable energy is available and what storage capacity in the battery would be required to enable the sharing of energy. Now that we got a grasp on the production and consumption, it's time to understand flexibility more deeply. The tool calculates energy usage patterns and allows us to see when these devices are in high demand. For example, between 10 a.m. and 2 p.m. our PV production is at its peak, while the electric vehicles, heating and cooling systems, and batteries are just some of the adaptable devices we can play with and plug them into the production peak time. This is called flexibility. By evaluating different profiles and taking consumption behaviors into account, the tool proposes usage patterns that can result in ideal opportunities for energy sharing and consumption, potentially influencing user behavior, such as routine suggestions. Using forecasting tools, residents can access their surplus energy availability, identify potential trading partners with complementary consumption patterns by running this simulation. However, it is important to know that we are aware of the technical constraints of the substation, which can be simulated using the substation feature in the tool. It is crucial to develop and incorporate a distribution key. Currently in Croatia, the sharing on trading of energy is not yet feasible. Until the regulations in Croatia allow that, we are learning by using simulations like this one. It is important to learn how peer-to-peer trading works, to foster informed collaboration and the understanding of sustainable energy practices within a community. All this helps us to be better prepared for the time when enabling regulations will finally be in place. What will give all citizens the opportunity to actively participate in the electricity market, which is our ultimate goal. Engaging in peer-to-peer energy trading through the tool can lead to cost savings for consumers. By accessing energy from the community power plant at a competitive rates and optimizing energy usage, we as participants can reduce our electricity costs. However, financial mechanisms would need to be developed based on the optimization. It is important to note that while the tool provides insights and analysis based on assumptions and input data, the actual energy sharing and trading transactions will require the development of a dynamic distribution key and secure transaction mechanisms. Additionally, real-time data on energy generation, consumption, and surplus availability would enhance the accuracy of effectiveness of the tool for peer-to-peer energy trading scenarios. Thank you for joining us on this educational journey through our virtual energy community to explore the potential of peer-to-peer energy sharing.